We're looking into programming the Kentucky Starter bot today. This is the layout of all the motors and sensors. You can see right here, this is the name that I'm going to use as far as that motor in the coding, and then also the port. For a closer look, here's the microcontroller. We're going to put our two limit switches over here in 2 and 3, and then we have our motors sort of set up in ports 2 through 10. The one thing to know about the way you set up your motors is that 1 through 5 and 6 through 10 are split with the way it looks at the amperage on the microcontroller. And so what you'll see a lot of teams do is they'll put the left side of their bot on 1 through 5 and the right side of their bot on 6 through 10, just to sort of spread out the voltage. The other thing to know is that this Wi-Fi key right here, it's very important that you minimize the vibration on it. And so there's 4 pins that are touching 4 pins inside the microcontroller here. And so if it disconnects in any way, it's an issue. And so allowing it not to vibrate is a real positive. So let's look at Robot C real quick. And what we're going to see is that in this software, we have a couple different templates that we can work with. One's just a new file, and the other one's a competition template. When we open up the competition template, it's going to look like this. There's a lot of notes here that you can sort of read through, which is great, and it sort of gives you information as far as what's going in. If once you get down to it, it sort of breaks it into something more like this, where you have your pragma, or the way that your motors are sort of set up on the microcontroller, your pre-autonomous, which is typically turning on displays, the autonomous for your program, and then your user control. Other things about the way the software works. In the robot, you do need to name your robot. If it's not named, it will sometimes have issues with the way it works. We can quickly fix our formatting, which is actually very beneficial because it shifts everything over here. Our motor and sensors are here, and so when I do this, it develops my pragma up here. And so I don't really type this, I just sort of plug it in right there. If we're having issues, we can download our firmware, compile our program, and then download it to our robot. So back to it. In the setups that I have for my motors, in my motors and sensor setup that we had on that button open a moment ago, I've gone through and I've labeled each of my motors in the different ports that they're supposed to be, and then I've set them to be VEX 395 motors. You do have different options under types right here. It doesn't really matter. I think it's really just for your reference. It's still going to send the same amount of voltage to it. So you can set it as high speed or high torque if you desire. But the one thing that you'll notice here that's different between my 1 through 5 and my 6 through 10 is that these motors are set to reverse. And what that allows me to do is when I'm coding 127, which is my highest speed going forward, I can set them all to 127 and not have to think about the left side of the robot turning clockwise and the right side of the robot turning counterclockwise. The other thing to know just before we move past this is that you cannot have spaces in the names of your motors. And so make sure that you get rid of that. And the reason is that when it comes down to the pragma, if you have that space, it sort of causes some issues with it. I've gone through and I've added my 2 limit switches for top and bottom, and I've set those both to touch. And so once we have both those set up, I'm going to select OK, and it goes down and it develops all this pragma for me, which is really nice. So again, just look at the competition layout. Our pragma that we just developed is going to go right here. We're actually not going to discuss our pre-autonomous functions. Right here between this spot and that spot is where that would go. We are going to discuss our autonomous, which is what the robot does before driver control. We are going to discuss the user control functions. So a simple autonomous to do is we're just going to move forward, lift the arm. We're going to continue that for ½ seconds. We're going to rotate left, stop lifting the arm, continue for 2 seconds, and stop moving. How we're going to do this is we're going to go right in that autonomous portion of the code, and we're going to bring in motor commands. So this one's going to be the motor. It's going to say which motor it is. So this is my right back motor, and I'm going to set it to 127, which is going to allow it to move forward. So this green part is actually a comment. And then I'm going to do this to my other 3 motors on my base. And then I'm going to set a motor here to lift my arm. And it's going to lift up for a certain amount of time. Notice it's going at half the speed as my motors. And then I'm going to delay for 15,000 milliseconds, or really 1.5 seconds. I'm then going to rotate my bot, and so you'll notice that my right side, my front and my back are still going forward, and then my left side are going full speed backwards. And then I stop lifting my arm by setting those 2 motors to 0. I delay, so I let it do that for 2 seconds. And then I'm going to stop my motor entirely. A good rule of thumb, this is probably not what you want to do for your autonomous. I would do this just to sort of try it out. A good rule of thumb is to sort of draw it out on a piece of paper and then build it as we go. So in other words, I'm going to figure out how far I need to go, maybe time how long it takes to get there, write my code, check that, then add the next step, then add the next step, then add the next step. It's also a good practice to add these comments in just so you can read pretty quickly what's going on with that part of your code. So our user controls are a little bit different. Let's look at the remote real quick. If you notice, the remote has these different spots where it's labeling channels on it. We're going to set up something that's referred to as tank drive. And so if I lift this forward, my left side of my bot goes forward. If I lift this forward, the right side of my bot goes forward. All right, and those are on channels 2 and 3, and it's sort of labeled on the remote. I'm not going to use 8 or 7 today, and that's primarily because one of my thumbs would have to come off that knob, which I don't like. And then I am going to use channel 6, which is going to be how I lift and lower my arm. So in my user control, again, I'm going in between those 2 brackets right there to write my code. It's going to be while true, and the reason it's while true is that it has to always do it. If I don't have that being a continuous loop, it's going to run it for the first millisecond and then stop the entire code. And what's going on is we're setting a motor command. We're saying take motor, the back right motor, and set it to whatever my Vex remote has channel 2 at. So whatever that analog value that it's sending is, set it directly to that. I'm going to do that for the rest of my motors for my base. Typically what I'm going to do when I'm programming this, I'm going to take a 12 pack of Pepsi and just set the robot up on top of that, and then I can sort of manipulate with the robot while it's tethered into the computer, and not have it drive off the table, which I think is very valuable. And so just to make sure those motors are correctly, and if they're going backwards or reverse, you might have to go into the motors and sensor setup and change those around a little bit. To get my buttons to work, I'm going to have it be where if Vex button 6 up right here is 1, so if it's pressed, do this, which is my right motor and my left motor for my lift going full speed. If else, so in other words, if it's not this, but it is this, my down's pressed, what I want to do is I want to take it down. If I'm reading this code, if I have both of these 2 buttons pressed, what's going to happen is it's going to run my first part here and not my second part, because it's going to be if, and if that's happy, we skip the rest of it. If neither of those buttons are pressed, all I'm doing is stopping the motors in their place. Moving forward. So the 2 sensors on this are set to keep the robot really from tipping over, keep it from stressing the motors out, because like if I'm going down, I keep pushing down, it goes against this brace bar, it will continually push and push and push and push until it either binds the gears, it can potentially break the gears. And so adding these limit switches in is a real positive thing. How you do this, I'm in my my driver control right now, and I'm just writing a statement that is, if the sensor value for the top limit, so what I'm getting from it, equals 1, or, that's a statement for or, the sensor value for my bottom limit equals 1, set both my motors to 0, else go ahead and run the standard setup that we have. It is a little complex because I have to have that little bracket down there to match it, because this whole portion is that else statement. But that's going to be just best practice for you to keep your robot up and running. This is the full code that I have, and so you can screen capture it. If I'm going to work with it, I'm going to set up my pragma first. I'm going to skip my pre-autonomous until I become more of an advanced team. I'm going to skip my autonomous, and I'm going to go to my driver control right off the bat. I'll probably try to set up to where my base works first, compile that program for me. Once that's working and effective, I'm going to go through and get my if statement here for my buttons to work and make sure I can do my lift. Again, I might have to toggle back and forth those reverses and those forwards as far as the motors go in my motion sensor setup. And then once that's good, I'm going to add my sensor value. And once I have all that set up for my user control, I'm going to go back and develop my task for my autonomous. That's pretty much the basics of programming the robot. Let me know if that works for you, and hopefully you have a good day.